And also, the semester is just a bit weird because it is like the first normal semester since COVID. Like the previous other semesters, they would still have to account for the fact that there would be large disruptions into the class schedule. I was still doing some of the things online for students who were uncomfortable with coming to class, but or felt they were sick. But since things are now normal, so to speak, for whatever given value of normal you want to take, we definitely, this is definitely the first kind of time, this is, again, first kind of normal semester. I know for a lot of people who are like your first semester here, this can be a lot. That's why I try to be very forgiving about turning in the homework. So if you've fallen behind, please catch up. And I still have to go through the emails to correct your exams if you emailed me. Sorry about that. I had to grade stuff for graduate school this past weekend and the like. So what are we going to do today? So today we're going to continue working on dictionaries in preparation for Thursday, which is one of my favorite lectures, which is where we're going to start talking about Monte Carlo approximations. Now, Monte Carlo approximations weren't really anything I learned until like my senior year or beyond in my undergraduate studies, because they sound really complicated, but they're really not. They're very, very nice mathematical tools that allow us to be lazy about doing mathematics. Namely, we can do math by not doing math. Instead, we can just do the thing. We're just instead of trying to predict what the mathematically calculate what the outcome of random events are going to be. We're just going to simulate those random events and count the outcomes enough times to actually get a result. Now, what is this? This is week 9 or is it week 8? I think it's week 9 at this point. Yes? Is it 8 or 9? 9. Let's see. So yeah, most likely the exam will be on week 11 or week 12, because what I want to make sure is that we've got plenty of time to do the Monte Carlo approximations and put that on the exam. The associated PIG assignment is 200 points. So like the homework 4 and 5, you get more time to work on it. We're going to do a bunch of parts of it in class, but I want to make sure you get some of that Monte Carlo approximation stuff on your second exam. Now notice that the due date for that is after the proposal and GitHub Lab. So again, I'll need to adjust these, and the proposal is right behind that. I've got to adjust those due dates to make to put them things. But namely, now's the time to start brainstorming about what you want to do for your final project. Not to decide on something, to start brainstorming, which is completely different. Okay? Completely different. Once we're done with this week, I plan on doing some amount of doing a lecture to teach you how to use GitHub, which is a great resource. But one of the things I have listed over here in Module 11, I want to make sure I've removed the verbiage for this. I used to let students do these for extra credit. Now, not anymore, because, let's see. Because what they are is that they are, let me turn off that extra credit bit, because they are not extra credit. They are optional assignments that can act as a building block for your final project. So first off, if you are completely lost and feel like you have no idea what you want to do for a final project because everything seems too hard and you're overwhelmed, and simply being able to do anything is too overwhelming, take a look at Module 11. Okay? Module 11 is where I got the idea for the final project from. I got it from the Harvard CS50 course. So if you want that, then all you have to, so if you're not sure what to do, the Harvard CS50 course has 3 tracks, or the version I'm using, that course, I had 3 tracks. A games course, a mobile development course, and a web course, okay? The games track went over how to make, it assumes you know some programming language, but it's done in Lua, which is a completely different programming language. It's a very useful scripting language used in some video games, and they use an engine called Love, which is a game engine written in Lua, and they teach you and they walk you through how to get that set up, and all the ways, and basically building Pong step by step, except for the bit where I think the other player controls the paddle. So they want you to program the bit where the AI controls the other paddle, but they show you everything up to that. And then they show you how to, and then Mario is just showing you how to make a 2D platformer. So if you want to do something game-shaped, but you need direction and structure, that's where you go. Basically take one of these projects and add your own spin to it. For mobile development, that's if you want to do, that's actually 2 different tracks. And if you want to do something on the iPhone development, that's one set of videos. If you want to do something on Android development, that's another set of videos. Keep in mind, if you plan on developing for iOS, you're going to need a Mac to do that. That's just the way it works with Apple. And then finally, web, which has a home page. So if you want your final project to be a web page, there you go. Or a more interactive web page, Stunks, which, if you're not familiar with, right, Stunks, which is a fake web trader where you are able to have a fake account trading fake money. But what it does, and the way it does that is that's just pulling the data. You make your orders and it's pulling in the data from real websites, real financial data. Yes.
What language are we using for that?
That one actually does use Python. It uses a Python framework. I think it uses Django, which is a fairly robust Python framework. But part of it is learning how to do HTML, CSS, and a bit of JavaScript, right? There is no exam 3. Ignored this gray out part. That was for I opted to do 2 exams rather than 3 because 3 became just way too tight. Took up way too much time. So again, no, you do not have to do these. These are options for if you are completely lost and overwhelmed, right, and don't know what to do. One of the things that I also love to suggest for students is who are feeling lost as well, is to try Ren'Py. So namely using Ren'Py to write a visual novel. This is a great way to get some, because so what are visual novels? They're essentially choose your own adventures with pictures. Some really good games have been made with Ren'Py. Specifically, I'm thinking of Doki Doki Literature Club, which sounds like it's very cute and weird, but instead is well, I'm not going to spoil it for you, but it's free, and you should definitely play it.
Did you?
What?
Did you play it?
Of course I did. I loved it.
Really?
I love Doki Doki Literature Club is exactly my jam. Okay, that kind of game is fantastic. But again, when it allows kind of a level of self-expression there, I do warn that you do not want to play this game, though, if you're easily disturbed. So that is the only warning I will give you. Check the tags if you aren't sure on that game, if you're not sure what I mean. But Ren'Py in general is a good way, but writing a choose-your-own-adventure game is pretty good. Some of the best projects from last semester were games that were made with Ren'Py, which is what was used to make Doki Doki Literature Club. I had people so last semester, I had a game where a team of 3, not only did they write the game, not only did they make their own assets, meaning their own drawings and music, but they also incorporated mini games, like a drag and drop mini game, into the game itself. So really using everything to its advantage there. A lot of games, and because that's done in Python and allows you a level of self-expression, that can be really exciting. If you're more musically inclined, then definitely talk to me because because you could write a VST for, I've had projects that some final projects have been VST plugins. There's different either instruments or effects plugins depending on your preference. I had a distortion plugin a couple semesters ago. I had somebody work in Pure Data, which was a lot like Max MSP, which is built into Ableton, the full producer version. So if you're interested in music stuff, let me know. If you're coming here and you're coming from an art background, you might want to talk to me. I could give you some pointers. I'm very open to very unique ideas, like that have to do with like AI and generation, that kind of stuff. All right, but that's enough about that. Just simply let you know that basically this is completely open. Basically we're looking for something that's going to take a few weeks worth of work. We're not looking for Hangman. Now, a version of Hangman that cheats and makes sure, and in such a way that the user never notices it, and makes the chances of winning that game infinitesimally small. Now, that's a version of Hangman I can get behind. Okay. Now, let's go ahead and get into our exercise for today. We can do that by going to Module 9, which is the Monte Carlo approximation and cheating at statistics. Note that this chapter does not have textbook readings for you. Please watch these videos. One done on the Monty Hall problem done by the Numberphile channel. This video that has an animation simulating a Monte Carlo approximation, as well as this one done by Mark Rober, which he's the one who does the glitter bombs. For the porch glitter bombs that basically catch porch pirates and spray them with glitter and stuff. So he did this kind of show, but here the reason I have this video linked is because what he's literally doing here is in Monte Carlo approximation to figure out the odds of a lot of these games, or at least some of the stuff here. The quizzes don't exist anymore. Don't worry about them. Today we're talking about Roman numerals. Okay. So that is what we're going to do today. So go to the Runestone textbook. If you are just simply on the Runestone website, right, just log in. The other way you can get there besides clicking is you can go to Runestone. You can log in. Hit log in. And then you just simply scroll down. Or you click on the Foundations of Python Programming and you scroll down to the project noted as Roman numerals. Converting Roman numerals. Now I had something like this as an interview problem when I went to interview at Google. So this is a problem that I know fairly well as a result now. So we have this picture. So this is a picture of the island of Gozo in the citadel of the city. I'm not even going to try to Virija. This small island that's part of the country of Malta, right? So very small island, and it's got these Roman numerals above the gate. MDCCCCIV. So Malta got conquered by a lot of people, including the Romans, and the Romans basically conquered everything at some point, it feels like. I mean, it's pretty huge. Common misconception that the Roman Empire died out in the 300s. It existed into what we considered to be the Byzantine Empire until the 1400s, But regardless, we got Roman numerals from the Romans, among other things. So, but there's a problem, which is that it doesn't follow the official rules for Roman numerals, because yes, there are rules. Of course there's rules. So the idea is that what they're trying to represent with this is the year 1904, okay? Now, the way Roman numerals work is the way a lot of early numerical systems work, which is that instead of using numbers, they use letters to represent numerical values. So here, M is for 1,000, D is for, I believe, 500. Yep, it's for 500. C is for 100, and then I'm pretty sure you've just kind of picked up from IV just simply through cultural osmosis and labeling of movies and names, meaning for. Okay. Now, for M and C, those are fairly easy to remember. You can remember M is 1,000 because M is short for millennium, 1,000, and C for century. Okay, that's how you remember it's 100. So there you go. You've memorized two more of those things without even trying. Okay. So the letters basically individually only have different values. They're either 1s or 5s. Okay. So I is 1, V is 5, X is 10. What's 50? 50 is L, apparently. Not really sure how to remember that. And then D is 500. C is 100. M is 1,000, and anything beyond that we're not going to bother with. You can see why people were very fond of taking the Arabic and Indian numerals and working with those instead, because they were a lot better. just straight up better. Okay. So here's the rules for them. You can repeat a numeral up to 3 times for addition. So you've seen III before, which represents 3. You typically see that in like the name of like somebody of the third person as a name. So III is 1 plus 1 plus 1, 3. You can only repeat values that are 1 values. They're like powers of 10. So 1, 10, 100, and 1,000. So I, X, C, and M. So I is going to be 1, X is going to be 10. You can do X for 20. You can do CCC for 300. V, L, and D should not be repeated because you can just simply because 2 V's would be simply X, and LL would be C. 50 plus 50 would be C, so write C instead. Right? You should simplify where possible. Okay. Next, what we do for sanity's sake is that we write everything from like we would do in the base 10 system, which is that bigger stuff goes on the right, the smaller stuff goes on the left. So you would write MC, not CM. And that's important because CM is a completely different number. MC would be 1,000 plus 100. XVI would be 10 plus 5 plus 1, so 16. Now, notice that we can only do like I, we can't do 4 I's, or in this case, 4 C's. Okay? You can't do that. 4 I should be written instead as using what's called the negation rule, which is where we get the IV from. Okay? And that simply says that writing a smaller numeral to the left of the larger numeral causes the sign to be negative. You can think of the IV as being 1 before 5. That's the easiest way to think of it. That IV is 1 before 5, meaning that it's 4. MCM XIV, so 1,000, 1 before 1,000, so that's 900, so that's what MCM is. And then XIV would be 10 plus 1 before 4, which is 14, which is 4. So 1,000 plus 900 plus 9 plus 5. Plus 10 plus 4. So now, take a moment to just kind of figure out what the right way to write 1904 is. They wrote MDCCCCIV, so instead we want to write the correct value for 1904. Okay? So take a minute or two to do that. There are no quizzes on Runestone right now. The only quiz we did was basically they were for when we were doing everything completely over COVID online. I still can show them to you as some practice problems later on, and I plan on using those, but the quizzes are not stuff that you have to worry about. That would be too much grading for everybody involved. Yes? D is 500. Okay. A few more seconds and I'll go and help you get there. So right before I get, so my last hint before we show you the answer, going from Roman to Arabic and Arabic to Roman are completely different processes. If you're going from Arabic to Roman, it's much easier if you look at every digit and try to convert each digit individually. And that makes it sound like super easy. And a 0 would just mean you don't do anything for that digit. Okay. All right, so now knowing what I just said, let's go ahead. So let's go ahead and do it that way, the way I just said. So 1904, that means that the first thing I want to convert is 1,000. So what's 1,000? M. Okay, the next thing I want to convert is 9, the 900. What should I do to do that? Yes? CM, yep. So why CM? Because that is 100 before 1,000. That's how I write 900. So now we've got 19,000. 0 would be, 1900. A 0 would be nothing. We just don't do anything for 0. And then 4, right, we know 4, that is 1 before 5. It's the IV. So now if we click check me, that is the correct answer. So now, if you haven't already, let's get some more practice over here. Match the Roman numerals to the correct Arabic numerals, right? And, metagame, if you have to. Use logic. All right, so again, let's kind of look at this So I'm going to do this as if I was taking an exam, which is I'm looking at this. So look, this one's shortest, so therefore it's probably the easiest, right? M, C, D. D is 500, one before, so 100 before 500 would be 400, so this is 1400 right over here. Okay, so there's two numbers here that end with 9, which is an IX. It would be these two guys, the top and the bottom. This one ends with an 8. It's the only one that ends with an 8. So it's got to be this one. 1998 is M, and if we check that, we see that's the case. MC M 4000, CM 900, XC 490, and then 8 VIII. And as a result, let's see, LV, we can again check this one. So that just leaves these two, which is MCM, so that's 1900, and MM, which would be 2000, D 500. Okay, now that you've got a hang of that, and you've gone through your Roman numeral hazing, so to speak. We've got now that we know this, we're going to write a program that takes this Roman numerals and converts it into something that's actually going to make sense to us, which is actual numbers. So what we'll do is that we're going to ask the user to enter a Roman numeral, validate it to make sure it follows all the rules. So we will, if the Roman numeral is valid, you should convert it to its Arabic equivalent. Print out the Roman numeral and its Arabic equivalent. So these are 4 separate functions that we could do, or 4 separate parts of the program. They're all independent. I mean, you can hook them up together, but you can code them independently, and that's what's important to realize. So I'm going to do part 3 first, which is I'm going to write a function, assuming, because this is the important one to me. We're going to assume the Roman numeral is valid, and we're going to convert it to its Arabic equivalent. Okay? Assume it's valid and convert it to the Arabic equivalent. Hint: you will want to start by using a dictionary to map each single character Roman numeral to the correct Arabic numeral. Okay? So, what should we do here? Right? If the Roman numeral is valid, we should convert it to its Arabic equivalent. Okay? So, there's a couple of different rules we can handle here. Right? Now, validating is basically just making sure that this doesn't occur, that we don't get something more than 4 times, a digit more than 3 times. It's essentially the only rule we need to worry about. And we just need to make sure that, numbers go from left to right. We can figure that part out later. Again, we can handle these in our validate, but most of this validation can be handled also by the convert. It can just be kind of written into conversion. But for right now, we're going to keep it simple. The hardest part of this is going to be this negation rule. So we'll ignore it for now. Yeah, just ignore it. If there's something that's causing too much of a problem to kind of wrap your head around and making it overly complex, ignore it just temporarily. Okay? Because that's an exception to the rule, and we can always add in that exception later. Or once we got an idea of how to solve it, we can always burn everything down and rebuild from scratch. That's always an option with programming. Never forget that it's always an option with programming, and sometimes it is the best option. It is a painful option, but burning everything down, starting from scratch, is sometimes the best way because, yeah, it feels like you've lost all that work, but what you've gained is a lot of experience, and now you know the right way to do it. Okay, so we're going to write a function here called convert. And we'll start out by taking in basically a string, which is our Roman. Roman. I'll just call this convert, and I'll call this Roman num. Okay? And what we're going to need to do is essentially a running sum here. So we're going to have a Arabic num is equal to 0. And at the end, we're going to return that number, Arabic num. I always like writing my functions starting out like this, basically creating what value I want to, defining what I want to return, because it's a lot easier to work towards a goal when you actually know what the goal is. Okay, so that's what. So we want to convert it to an Arabic numeral. That sounds like we need to do a running sum. Now, what we would want to do for this is that I'd want to go through every number in this and convert it. Okay, again, we're going to ignore the negation rule here. Okay, so what does that mean? It means that if we're going to do, if we see this, it means that basically we can just start programming. What we're going to do is we're going to say for a letter in Roman num. That's because what we're going to do is that, remember, the Roman numeral is like a bunch of letters. We're going to iterate through it. And what we need to do is we need to take each of those numbers and convert it one at a time. Basically, I'm going to write pass here because you're going to fill that in. But get the Arabic value for letter. Get, and then add that to the running total. Now, getting that the Arabic value for that letter, okay, we could do that as basically as a bunch of if statements. Oh, if it's an I, add 1. If it's an X, add 10. If the letter is something, add another 1. But honestly, that's just going to be, that would make my code really long. Instead, what we can use is we can take advantage of a dictionary. Okay? So instead, what we're going to do is we're going to say D, we're going to set up our a dictionary call, and I'm going to call it Roman to Arabic. I'm not going to add anything else to it. But the way I'll do this is I'll just simply I'll set up a key value mapping, basically a way to convert a dictionary. I'm setting up a dictionary to convert one thing to another thing, right? Think of it like an actual honest-to-God dictionary where you're given a word and a definition. Here it's letter, and what does that letter actually mean in this context? So here, for instance, the letter I means 1. The letter X means 10, and so on and so forth. So there's 8 total digits, right? So we'll need to put those all in. So, okay, go ahead and get started over here. I'm going to, so let's, like I said, I'm grab some of my other stuff for easier reference. So first off, let's go ahead and finish that dictionary. The finished dictionary should look something like that. That should be your first step. That's all you got. It's okay, because we're going to actually need to burn most of what we wrote for reasons we'll see. But the way I would do what we wrote is, okay, we need to get the Arabic value for the letter. So that's simply done by saying value is equal to, like the numerical value for that letter is equal to Roman to Arabic letter. That's how we do, that's all you have to do to get it out. Given this dictionary, we take that letter, we give it to the dictionary and ask, hey, can you give me the value for it? So if we pass in a 10, it's going to give me a 10. If we pass in if we see a 100, we're going to get 100 out here, and then we add it to the running total. Okay? Which we're going to do by saying Arabic num plus equals value. And, this is going to work for a lot of cases. It will work for, so here I'm going to do print, convert, VII, so this will give me 18, right? Save, and that gives me 18, no problem. If I want to do 16, that would be XVI. The only issue runs into if I want to do 14, XIV, which I hit save and run, because that's going to give me 16 again. Because again, we aren't doing the negation rule here. To handle the negation rule is, now again, assuming we're being passed valid, Roman numerals, so we don't have to worry about validation quite yet. But to do this, okay, we can't just loop through it, unfortunately. This for loop means, when we do a for loop like this, the for letter in Roman numerals, we're kind of, limited to what is there. Yes, there's also enumerate. We could wrap an enumerate around it to get the index, but that makes things a bit tougher. And it's not going to work for your homework either, because both your homework and this have the same problem, which is that we want to figure out if something needs to be negative, we have to look ahead. That's what we have to do. We have to look ahead to the index. Okay, so what do we need to do? Well, we can't use a for loop anymore. Okay? What we need is, instead, we're going to need to manually iterate over it with a while loop and using the index. And you'll need to do this for your homework as well. Index is equal to 0. And instead of doing this, what we're going to do is we're going to rewrite it into an equivalent while. I'm going to rewrite what we have here to an equivalent while loop before we start making changes. Okay? How do we rewrite it to an equivalent while loop? So what we're iterating over is the index. So each iteration of the loop, this index should go up by 1, right? Not true for your homework, though. For your homework, it depends on, yes. It most of the time will go up by, so right now, yes. For what we're doing right now, it should go up by 1. I'll try to do this in a format that's equivalent to what you need to do for your homework to kind of lead you to the right path on your homework, okay? So right now, for doing the equivalent, that's going to make sense. So this will be a while loop. While index, now what we want to do is we want to go over all the valid indexes, or indices, right? If we have x, so let's go ahead and turn this into 18 again. X, if we have 18, let's go ahead and just simply type out our indices, right? 0, 1, 2, 3, 4. This one is length 5. That means that the indexes are 0, 1, 2, 3, 4. So we want index to go over all the values from 0 up to, but not including 5. So while index is less than length of Roman num minus 1. Is it not minus 1? We'll get to that minus 1 in a bit. Right now, it's not minus 1. Because right now, we're just doing an equivalent code. Roman to error. Okay? So we're not there yet. So we have index. We no longer have letter. So we're now iterating over the index, but we don't have our letter. Right? This iterates over the index just fine. So now that we're going over the index, when we're at each index, we're going to want to get the letter at that index. Make sense? So what we'll do, and again, this is equivalent to what we had written earlier. Letter is equal to Roman num index. Okay? So that now it's exactly the same. We've changed this line, and we've added this line, and this line. It's a lot more work, but now we have manual control over it. So index is equal to 0. While the index is not out of bounds, grab the letter at that index, convert it to that value, add the value to the running sum. We can actually simplify that, but for right now we're not going to. And then we're going to add 1 to it. Now, so why did we do this? Why did I do it like this? And the reason is because to do this negation rule, which is for for instance, to do 9, ix, to do 9, if I just do it the way right now it's written, it's going to be 11. But what I want to be able to do is 1 before 11, meaning that this 1 needs to be negative, right? This 1 needs to be negative. So that becomes negative 1 plus 10, as opposed to 1 plus 10. Now, the negation rule up here states to write a number that would otherwise take the repeating of a numeral 4 or more times, there is a negation rule. Writing a smaller number to the left of a larger number causes the sign of the number on the left to be negative. So in other words, because I is smaller than x and I is on the left, I becomes negative now. Technically that would work for this as well, but again, why would you do that? You would just simply write, you would just simply write 5 as opposed to 5 before 1. Sorry, 5 before 10. So here, this would be negative 1 plus 10. So in other words, what we have to do in order to figure out if something is negative is that we have to look ahead. This is extremely relevant to your homework with double vowels, by the way, in case you're wondering why I'm going over this. Okay? This is extremely relevant because for double vowels, you're also going to have to look ahead. And you can't really look ahead with the standard for loop. You have to use that while loop to really want to look ahead. Okay? What do I mean, look ahead? Well, what I mean by this is that we could get the letter at index, okay? And we can also grab the next letter so we can compare it, because that's what we have to do. For this letter, I need to figure out whether this letter is positive. For this letter, I need to figure out if the value is going to be positive or negative. In order to do so, I have to look one ahead. Okay? So take 1 minute. It's 1 minute to finish this line. Next letter is equal to what? Okay, let's just take some time to figure that out. Just insert that one in. Yes? I will share my code after I'm done writing this part for the next slide. Which is now callable. No worries. They always see what they want to see. Yeah. Training the eyes to see what's actually there is like really hard. All right. So if we're currently at index, and the letter at index is located at index, then the next letter is at Roman num index plus 1. Right? Index Roman num plus 1. Okay. So what does index, so the way I like to read these when you have index and index plus 1 is you think of this one as index plus 1 means 1 to the right of the location I'm currently at. Okay? So that makes sense. If this is index 0, index 1 is going to be x. Okay? But now, in being able to do that, we've caused ourselves a bit of an issue. Next letter is assigned but never used, and then there's the error, string index out of range. So I'm going to share this code with you for right now. But the idea here is that now that we're looking ahead, we're going out of bounds. Why? Well, because let's just go over again to x, v, I. So 18. When we're at x, we're going to look at v. When we're at v, we're going to look at I. When we're at I, we're going to look at the next I. When we're at the middle I, we're going to look at the final I. And when we're at the final I, we're going to look at index plus 1 for that. So we're at index 4. What is index plus 1? What is 4 plus 1? 5. And 5 is out of bounds here. So think for a second, add it to your code. What do we need to do to stop that error from occurring? That will require adding codes elsewhere in this, by the way, to fix to fix that. We're playing a game of whack-a-mole with errors and bugs. But I promise you it is worth it. And if we don't get to the going the other way, that's perfectly fine, by the way. Going the other way is a bit easier. But this part is the important part for your homework, for the Hawaiian pronunciations. That's why I'm going over it. All right. So the easiest way to solve this problem for us right now is the issue is that when we get to the last character, we look ahead, right, to the next character. But the next character may not exist. So what we're running into is basically whenever you have this issue where you're looking ahead, you want to stop one index early. That's what you want to do. There's another solution in Python, though, that your homework does use, but for right now, I'll show you the general solution to that, which is to do this. When you're at the last, basically stop your loop. Your loop should only go through these first 4 characters and not the last one, because this last one needs to be handled uniquely. This last number is always going to be positive, by the way, because there's nothing to the left of it. So because it's left out of the loop, we have to handle it by itself, which is that we will just simply do that by doing this. Arabic num plus equals Roman to let's see. To Arabic Roman num -1. Yeah, this looks a bit complicated. I just simply made a one-liner where I could break it up into multiple lines. What this says is that we're going to take the very last letter, convert it from Roman to Arabic, and add that last number in by itself. Now we can run this code, and we can see that we get the answer that we needed again, 18. So now it's working again, although we haven't done the negation part. All we've done is made it so we can handle the negation now. Okay. Seems like we did a lot of work for nothing, but trust me, it was worth it. So what we need to do is basically figure out, should we be doing Arabic num plus value or Arabic num minus equals value? Personally, I like to always do Arabic num plus equals value and just simply make it negative, instead. So it makes it easier to code. But now what we've been able to do is we can take the letter, the next letter, and we can get the value. Now that we have the value, we should get the value for the next letter. What do I mean by that? Next value is equal to Roman to Arabic. Next letter. So we've gotten the letter I'm currently on. So if we're at index 0, that would be 10. Sorry, X. If we're at index 1, next letter would be V. And so now I'm getting 10 and 5. Okay? So the next step is that negation rule to figure out if the thing on the left is smaller than the thing on the right, then we want to subtract value. If it's bigger, we just do the normal thing. Make sense? So go ahead and take a few minutes to program that one. Then we'll see that we've pretty much got this working. Believe it or not, this is going to be completely working after that point for the conversion process. And then we'll see about playing around, and then I'm going to play around with it a bit in a way that doesn't necessarily make sense for this assignment, but it will make sense for your homework, which is what we really care about, I know, right? Oh, and right? You'll want an if statement. That's what you need over there. If you're finding this one hard, that's okay. You're kind of approaching the maximum value of moving pieces that a person can keep track of, which is about 4 to 7, depending on the contents.
If this index where we have it, that is 0, it'll be 0, then 1, then 2, then 3. It'll be whatever. So it's hard to say when it's change. Makes sense? And 0 less than the length of the.
Yeah, that's one of the word, and that's how those are. Right? Okay, if you're still stuck, here's another bit. What we want to do is check if the value, our current value, is less, if the value on the left is less than the value on the right. Then the value should be negative rather than positive. Okay, so to complete that, what you should have at this point is if the value is on the left is less than the value on the right, if it's smaller, like we have ix or iv, then that I should be negative. So there's a couple ways to do that. First way we could do that is we could do an if-else statement and indent that. And this is the way I don't prefer to do it because it requires an if-else statement when I can just, do that. So if it's less than the value, subtract it. If it's greater than, add it. Okay? The way I prefer to do it, though, is just always add. This is just my personal preference after doing stuff for years. And just turn it negative by multiplying by -1. -1's a handy tool to keep around. Okay. And then we can save and run it. 18. And now if we try 14, it works. If we try, and finally, if we try our string from earlier, 1904, MCMIV, we should get 1904. So this works. Now, again, why am I talking about this? Now, in your homework, you'll have 2 dictionaries. Okay? And basically, you want to figure out, is it double a vowel by looking ahead and seeing, hey, is this 2-vowel sequence if this 2-vowel sequence is, something that's a valid 2-vowel, if these 2 letters make a 2-vowel syllable, okay, like A and I making the I sound, okay. Now, the way we do that is looking ahead, but there's one kind of cheat we have in Python, right? There's a cheat we have in Python that doesn't require us to look ahead. Okay? Which is as follows. So I'm going to go ahead and save this and run it. I've already done so. I'm going to share this with everybody so they have a copy of this one. Okay? Before I start butchering this code to make a pedagogical point. Okay? So this -1 is annoying. Let's get rid of it. Okay? What we'll do here is we will say, hey, we've got this letter and next letter. What we could do alternatively is also we could do, with Python, we can do letter pair. What? What am I talking about? I'm talking about doing this. Letter pair is equal to Roman num index to index plus 2. So that's a slice. Python has slicing, and the wonderful thing about slicing that I didn't know until I started teaching, this 1051, not this semester, but until I was teaching 1051 in general. The wonderful thing about slicing, okay, so S is equal to apple, S from index 2 to some huge number never goes out of bounds. Slicing does not go out of bounds for some odd reason in Python. Don't know. But you know what I see when life gives you lemons, make lemonade. So or something like that. So if we see an exploit, you bet I'm going to exploit it. So here I don't have to look ahead at a single index anymore. I'm just going to grab letter and maybe I'll call it letter and next. Okay? And what we can do now is just very simple. Or not very simple, but we can kind of play along with this. So first off, if letter and next, if that is just one character long because we're out of bounds, right? If it's just one character long because we're on the last letter, then there is no next thing, so it's going to be 1. So if that's equal to 1, now this isn't necessarily the structure you're going to want to use for your homework, this if statement I'm writing. But this thing, this line 7, you better pay attention to that. Okay? If that's just that, okay, if its length is 1, what we're going to do is that we are going to just simply do what we normally do, which is I'm going to say Arabic num is equal to Roman num, num is equal to Roman to, oh yeah. And I forgot one important character over here, plus equals. I'm just making it one line as opposed to 2 lines, okay? Make sense? And once again, I'm going to burn everything down over here. Why? Why are you doing this, Professor Rosen? You worked so hard on this. Why are you burning everything down? To make a point. A very important point that you have to learn. Burning things down is important sometimes. Okay? So, there's basically 3 cases that we're dealing with here. 1, letter and next make up a pair of letters that need to be taken together. C and M make 900. Or I and V make -1 and 4. Otherwise, the case number 2, just the letter by itself. And case number 3 is something like this. CV, that's short. CV, where the I is just the last letter. So that's what's been covered over here, last letter. And if we read one letter, we're just going to say index is equal to index plus 1. We're going to move up one letter. If letter, so let's go ahead and say if len letter and next. I'm doing it this way specifically. This is not the best way to order things. I'm doing it like this so that it will make sense when you look at this lecture again when you're doing your homework, okay? Equals 2. You're not going to need this so much when you're doing your homework, but it's very useful to have here. So if it's equal to 2, if I'm going to get again, what you want is kind of the thought process here. You'll see in a second what I mean. If letter, val is equal to, value is equal to letter, Roman to Arabic letter. Next and then we can go for next value as well, because because if it's too long, we know it has a next value as well. It's equal to Roman to Arabic letter and next 1. Oh, that looks awful, but it's okay. Basically, this is not something you'll have to worry about in your homework. I'm just doing it like this so I can get to the point. I'm getting the value and the next value just like we did. I've just kind of compressed our operations now, where I take the second part of this pair, okay? And I know there's going to be a second part because I checked if it was 2. And now we ask our important question. If value is less than, and this is actually a worse way to do it than I did before, but again, the reason we're doing it this way is your homework. Value is equal to, if value is equal to next value, colon, sorry, value is less than next value. So if it's less, that means it's negative. Okay? And here I am going to make it an if-else. And you'll see why in a second. If value is less than next value, what I'm going to do is that, that's the case where basically where we have, like, instead of 118, I might have 104. This is the IV case. Since we know that's the case right here, and I've got these values right in front of me, I might as well calculate it right now. It should be Arabic num plus equals value times -1 plus next value. But then here's the important bit. This is the entire reason for doing this part. And let me go ahead and test my code, by the way, to make sure that I'm not just making this up. 104. Great, it works. And let me just check this thing to make sure it works as well. Because I literally came up with this on the spot so I could help you with your homework. Okay, this is the important bit over here. Now, what I've done over here is that I've checked, okay, is this chunk, so I've gotten, I didn't just get the letter. What I did is I got the letter and the next one, and I checked, hey, let's in fact, I can make it like this instead. If it's equal to 2, I'm going to get both values, and I'm going to check. If we're like in an IV or an IX situation or a CM situation, then this is easy enough to handle. What I'm going to do is I'm going to say Arabic number is, if we're in one of those negation rules, what I've done here is I've went ahead and computed just not just this number, but this number and the next number as well. And because I've added in this number and the next number, I've incremented my index by 2. Okay? Otherwise, if I'm just, the number is just, if it's a normal situation where basically where the numbers are in the proper order, I just add the number and increment by 1. So, on a completely related note, when we are going through your Hawaiian word, when we do K key, we see a consonant, so we just output a consonant. Or rather, I see a consonant, I'm at K, I'm going to check the next letter, K-E. That is not a double vowel. This is the logic I use, okay? Going to start at K. K is not a vowel. Sorry, K-E is not a double vowel. Okay, great. K itself is not a vowel. It's a consonant, so I'm going to output K and increment and look at the next index. Next, I'm at index 1. I'm going to look at the slice that includes 1 ahead. Is AE a double vowel? Sorry, EI a double vowel? Yes, it is. Okay, so I'm going to go to the dictionary, I'm going to grab that syllable, and then I'm going to increment by 2 my index. Why 2? Well, because I read a double vowel. If I only incremented by 1, my next thing would be K-E, which is not how it works. It's just K key. It's not K-E key, it's K key. So incrementing by 2, because this is a matched set over here, like we did over here, that I and V, that I and X, that C and M, I'm considering them a matched set over here. So I increment by 2, now I'm at index 3, same logic occurs here. Index 3 says, is Ki in the double val? No. Is K in the val? No. Is K a consonant? Yes, it is. Output the consonants. By the way, anytime you output a val, follow it with a dash so you can separate stuff. Output a K. And now I'm at I. I'm going to look at the slice of I plus the next letter, including it. It's because it's a slice, I don't have to worry about going out of bounds. Makes it a lot easier, less edge cases. I is not in that slice, is not, which is just simply I, is not in the double vowels. Okay, look at the current letter, which is just I. Is that in the vowels? Yes, it is. Okay, get the value out of the dictionary. You know, the key is I, the value is E, and because it's a dash, and we're being very silly about this and very simple, like I said, anytime I do anytime I do a syllable, a vowel syllable, I'm going to output a dash because that's what separates syllables. Vowels separate, all syllables are separated by vowels. Okay? So now I'm done with this, and I know that and because of the way I've written this, I know that my program is always going to output something with an extraneous dash at the end. So what you do is just simply remove that last dash and you get K key. The same logic applies for aloha. Aloha. Is this in the double vowels? No. A is in the vowels, so we'll do and dash. Increment by 1. LO is not in the double vowels. L is not in the vowels. It's in the consonants, so we're going to go L. OH is not in the double vowels. O is in the vowels, so I'm going to go O. And then increment by 1. H is not in the A is not in the double vowels. H is not in the vowel. H is a consonant, so we output H. Increment by 1. A is not in the double vowels. Sorry, A is not in the double vowels. A is in the single vowel, so we'll do aloha at a dash. We're done. Take away the very last dash, and you got it. Once you've done it, the pronunciation is surprisingly short. So here's what I'm going to do. So I'm going to share this code. Okay. What I'm going to do is I'm going to share also this is valid code over here in case you want to take a look at it yourself. Share that. And then I'll probably have to regrade it to leave out this bit because we didn't get to the this part, but that's okay. I wanted to make sure we got to this part. And stop recording.